I'm going to go through the answers to these questions. If you haven't actually done these questions yet, then please pause the video, do the questions by yourself, and then press play again when you're ready to go through the answers. Okay, so the reason I've included this table is that those of you who have done the quiz online, these are the questions that you struggled with, so I just want to go through this again. Okay, when you're predicting the product at the cathode and the anode, the first thing to take note of is just the state symbol. So for the first four here, I've written in brackets that they're liquid. If they're liquid, it means that you have melted them. And if you've melted them, then there is no water present. Okay, there's no water present. The only things that are present are the elements that you've actually got in the compound. So in the first one, all you've got present is sodium and fluorine, then you've got calcium and chlorine, then you've got aluminium and bromine. So they're your only possible answers when you're predicting your product. The cathode is negatively charged and the anode is positively charged. Metals are always positively charged when they form ions, so metals will always go to the cathode. Metal is always the first word. So for these ones that are liquid, all you're doing is taking the first word from the compound and writing it underneath the cathode. So the first one, you're going to have sodium, then you're going to have calcium, the next one's aluminium, and then you've got copper. At the anode, okay, you've got the non-metal, which is the second word. When you're writing the anode, it's important that you write it as it is on the periodic table. So it's not fluoride, it's fluorine. It's not chloride, it's chlorine. It's not bromide, it's bromine. And again, it's not chloride, it's chlorine. The next ones, you see that they have aqueous after them. And if it's aqueous, it means you've dissolved it in water. Because you've dissolved them in water, as well as having the elements in the compound, you've also got hydrogen and you've got oxygen from the water, and that's going to affect your answer. So in general, if it's aqueous, okay, you have to look at the metal. If the metal is not copper, then hydrogen is going to form at the cathode. You're getting this hydrogen from H2O, from water, okay? And if you don't have copper, hydrogen's going to form. The next one, it's aqueous, the metal's not copper, hydrogen's going to form. The next one, it's aqueous, the metal's not copper, hydrogen's going to form. The next one, it's aqueous, the metal is copper, so copper forms. The last one, it's aqueous, copper is the metal, so copper forms. So when it's aqueous, at the cathode, your answer is always going to be hydrogen or copper. If copper is your metal, the answer is copper. If copper is not your metal, the answer is going to be hydrogen. At the anode, the answer is going to be the same as what we had above, okay? If you've got a group 7 non-metal, the group 7 will form. So you've got fluorines in group 7, that's going to form. You've got chlorine, that's in group 7, bromines also in group 7, and then chlorines also in group 7. But in the last one, you've got sulfate, okay? Sulfate is made up of sulfur and it's made up of oxygen. Neither of those are in group 7, so we can't use the rule that we've previously been using. Out of sulfur and oxygen, it's the oxygen that forms, which means at the anode, your answer is always a halogen if you've got a halogen, and then it's oxygen if you've got sulfate. Okay, if you look at the next question, this is slightly more physics-based. They want to suggest an improvement to show that this circuit is actually working, to show that there's electricity flowing around the circuit. And if you wanted to do that, you'd simply put in a light bulb. And if the bulb is lit up, then you know that you've actually got electricity flowing around your circuit. What is meant by the term electrolyte? This is for 2 marks, okay? You have to say a substance that can conduct electricity. So you get 1 mark for mentioning conduct electricity, and you get your 2nd mark for saying when it is molten or in solution. So you can say molten or aqueous or molten or in solution, okay? 1 mark for conduct electricity, 1 mark for molten or in solution. So if you were to look at these solutions here in the box, and if they asked you which one is an electrolyte, you would say J is an electrolyte because when it's in solution, it conducts electricity. K is not an electrolyte. L is an electrolyte. In the next question, okay, it asks you to calculate the mass of copper deposited. So we see at the cathode that the metal always goes to the cathode, and the metal is going to build up and form around the cathode. And you'll see that the cathode started off with a mass of 1.28 grams and then ended with a mass of 1.57. And they just want to know how much copper was actually deposited onto the cathode. So it's just 1.57, the mass at the end, minus the mass at the beginning, and that gives you 0.29 grams. You get 1 mark for showing the calculation, 1 mark for the answer. If you just gave the answer, you get 2 marks. Identify the products formed when the molten. So here I've got that word molten. Molten is the same as liquid, so there's no water present. All you've got present is potassium and you've got iodide. Potassium, that's your metal. The metal always goes to the cathode. Remember, the metal's always the first word, and the first word goes to the cathode. Then you've got iodide, but I have to write it as it is on the periodic table, which is iodine. The next one, chlorine is produced as one of these products. What is the name of the electrode where chlorine is formed? Okay, so you have got, they've showed you here, you've got a positive electrode and you've got a negative electrode, and they've shown you that chlorine is forming at the positive electrode. We remember panic, and we know that the positive one is called the anode. So this one here, where chlorine is forming, is the anode, which means my answer is B. State the name of the colourless gas formed at the negative electrode. So they're telling you you're forming a gas here at this negative electrode. Okay, the negative electrode is the cathode. And they're telling you you've got sodium chloride solution. So when it's a solution, that's the same as being aqueous. And we know that if it's aqueous and the metal is not copper, then the product is going to be hydrogen. And that fits with the question because hydrogen is a gas at room temperature. So hydrogen is forming at the cathode. Describe a simple test that show an alkali form. So this, again, doesn't really have anything to do with electrolysis. This goes back to acids and alkalis. If you want to show something as an alkali, you're going to use an indicator, okay? If you just write indicator, you'll get 1 mark. But if you actually give the name of an indicator, so I'm going to say universal indicator will turn blue. So to get 2 marks, you need to name an indicator and then tell me what color it's going to turn. You can say blue or you can say purple. You could have used litmus paper and said it would turn blue, okay? But just give me a name of an indicator and then give me the colour change. Solid sodium chloride does not conduct electricity, why, blah, blah, blah. Okay, we've seen this lots and lots of times, so I'm really hoping you all got this right, okay? When it's a solid, the ions are not free to move. Okay, you have to use the word ions. When it's a solution, the ions are free to move and can carry current. You can't just say particles, you have to say ions. You can't say the localized electrons. So you get 1 mark for mentioning ions, you get 1 mark for saying that they can't move in a solid, and then you get a 3rd mark for saying that they can move in a solution. State what could be added to the circuit to show that electric. Okay, so this is very similar to what we've already had. If I want to show that electric current is flowing, I can add a light bulb. The other thing you can add, again, it's a physics term, is an ammeter. What is the name of the electrode where hydrogen is formed? Okay, hydrogen is formed here at the negative electrode. I know the negative electrode is called the cathode from panic. Gases are produced at both electrodes. State the name of the yellow-green gas formed at the positive electrode. So they told you, so this is my positive electrode, this is my anode, and they told you you're forming a gas at the anode, okay? I know when I've got sodium chloride, even if it's a solution, that it's always the halogen that forms at the anode. The halogen is chlorine, and chlorine is a yellow-green gas. So my answer there is chlorine. How would I show that the gas formed at the negative electrode is hydrogen? Okay, that's the Squeaky Pop test. You can't just write Squeaky Pop. You have to say how you would do it because it asks you to describe the test. So I'm going to say lit splint. So you're putting, it's not right, put lit splint into gas, and then you hear a squeaky pop to tell you the hydrogen. And then again, similar question, why can sodium chloride solution conduct electricity? They're not asking about a solid, they're just asking about the solution. So you're just going to tell me that the ions can move and carry current. Again, you need to mention the word ions and you need to tell me that they can move. If you've got any questions or any of those, just log back into the meeting and ask me, and we stay online for the whole lesson. And when you're finished, done all the questions, you've marked all your work, please take a photo and send it to me.